Hi everyone. Myself, Varshit Reddy. Today we are going to present about a paper published by Mrs. Jyoti on and his teammate and her teammates from Microsoft on Morpheus towards automated SLOs for enterprise clusters. This paper mainly focuses on codifying implicit user expectations as explicit service level objectives. Basically, they are called as SLOs. And one more objective of this paper is enforces SLOs using novel scheduling techniques. These techniques isolate jobs from sharing induced performance variability. And they also mentioned about mitigating inherent performance variance. This can arise due to failures, and the mitigation will be done by the means of dynamic reprovisioning of jobs. Now we will see what all are they presented in the paper. The main motivation of the paper is to give an entire overview in similar words. Uh, In simpler words, a system called Morpheus is designed to help large companies manage their computer clusters more efficiently. The scenario is like this. A computer cluster is a group of computers that work together to process large amounts of data. And many companies use these clusters to run their businesses' critical data analytic jobs. A problem that can frequently occur and is unpredictable and happening with these clusters is that sometimes jobs take longer to run than expected, which can cause a negative impact on businesses, as we know. This can happen because of inconvenient allocation of resources across job runs or because of changes in job input or hardware failures. Now, here comes the Morpheus has tried to address these problems by automatically inferring what users expect from their jobs and then using novel scheduling techniques to control variability in job runs. Morpheus also tried to cope with the inherent unpredictability by dynamically reprovisioning jobs as needed. As you can see, the execution logs of millions of jobs runs on clusters with more than 50K nodes. The researchers tested this Morpheus on 50K nodes cluster and found that it can reduce deadline violation by 5 to 13 times while still maintaining high cluster utilization. They also deployed Morpheus on a smaller amount of nodes, which is around 2,700 node cluster, and found that it was scalable and practicable. But how does Morpheus achieve that? That's a bigger question. Firstly, it addresses inferring of service level objectives and modeling job resource demands. Next, it controlling sharing induced unpredictability and then coping with inherent unpredictability. The initial problem is to explicitly state the implicit user predictability expectation in a way that the underlying resource management infrastructure can exploit. Morpheus achieves this by using hardware-based memory encryption scheme that enables frequent and unpredictable changes to the mapping between virtual and physical memory addresses. And also, Morpheus includes a set of runtime support libraries that help ensure the code and the data remain are self-contained and isolated, further reducing the risk of information leakage and code ingestion attacks. Uh, the proper exp- uh, the proper execution of project jobs is also crucial. Uh, but we'll once again see how it tackles the unpredictability. The resulting categorization is that we refer to as service level objective, which is called SLOs. We concentrate on deadlines or SLOs to completion times. The following stage involves estimating how resources will need to be provided during the job execution in order to fulfill SLOs without needly over provisioning resources. Now, for enforcing SLOs while retaining high utilization in a shared environment, we need to eliminate the share induced unpredictability. This involves controlling performance variance with minimal resource over provisioning. The next target is to deal with inherent performance variance. This is done by dynamically reprovisioning the current instance of a reservation in response of job resource consumption in a relation to SLO. The constant for short-term drifts while continuing retaining of our SLOs and job resource model extractors, uh, capturing long-term effects. Now, the challenges in building Morpheus. They have seen a lot of challenges. So let me highlight the challenges occurred during the building of Morpheus. Uh, the automated clustering user predictability expectations, controlling shared induced unpredictability, and one is coping with inheritance unpredictability. Now, let me highlight the unpredictability that can be faced. In my point of view, shared induced performance variability caused by inconsistent allocation of resources across job runs. And one more is inherent performance variability due to changes in the job input. The source code tweaks and the failures and the hardware also chunks. Uh, Let me come here. Inferring SLOs and modeling job resource demands to formalize the implicit user predictability expectations in an explicit form that is actionable for the underlying resource management infrastructure. And eliminating shared induced unpredictability to enforce SLOs with retaining high utilization in a shared environment, mitigating inherent unpredictability, dealing with inherent performance variance, for example, such as task failures, code data changes, etc. This is done by dynamically reprovisioning the current instance of reservation in response of job resource consumption. Allowing me to highlight the cluster overloads and the predictability changes now. Proper execution of production jobs is crucial. The production jobs present over 75% of our workload and a similar percentage of provisioned capacity. The rest being dedicated to ad hoc jobs like 20 to 10 to 20%, and ready to handle growth failures from about 5 to 10%. All unassigned capacity is redistributed fairly to speed up jobs. And the next one is predictability trumps fairness. Future analysis of exaggeration of, if you see in the figure one, Um and of discussion threads, it is evident that users are 120 times more likely to complain about the performance unpredictability that about fairness than about fairness. Uh, but our system does not enforce fairness strictly. Now, coming to the production jobs are often periodic. Over 60% of jobs in our large clusters are recurrent. When you see in the picture B, the distribution of period for periodic jobs, interestingly, most of the distribution mass is contributed by small number of natural values, like for an example, once a day, once an hour, etc. This evidence confirms that the most important portion of workloads is undoubtedly recurrent. This allows for planning the cluster's agenda without being overlying conservative in the resource provisioning of jobs. One of the key predictability changes to highlight here is that the action of manual tuning of a job allocation is really difficult. The other key points that are being highlighted are include randomized layout of code and data segmentation, existing defense mechanism for such attacks, inadequate forces on detecting what attack patterns cannot prevent attacks that exploit novel vulnerability. Now coming to the design, before deep diving into it, please give me a glance at some other points that I have additionally marked here. Uh, Now let me jump into it. The key ideas for design principles are Morpheus is designed to protect the confidentiality of software running on a computer system, even in the event of a successful attacker compromise. One of the key ideas behind Morpheus is to constantly change the layout of a program's code and data in memory, making it much more difficult for an attacker to allocate sensitive information and exploit vulnerabilities. Now, Morpheus also achieves this by using a hardware-based memory encryption scheme that enables frequent and unpredictable changes to the mapping between virtual and physical memory addresses. Morpheus also includes a set of runtime support libraries that helps ensure that code and data remain uncontained and isolated, further reducing the risk of information leakage and code injection attacks. Other key points in my mind are the design of Morpheus is flexible and configurable, allowing system administrators to balance security and performance requirements based on their specific needs. And also, Morpheus has been implemented and tested on a wide range of hardware platforms and software environments, demonstrating its efficiency and practicality in real world scenarios. Now, coming to the architecture of Morpheus, from now on, my teammate Balayogi will continue from here. Let me give control to him. Yeah, you can go on.
Hi, I'm continuing from the understanding architecture and the conceptual view of amorphous architecture. This architecture contains various parts of like automatic inference, recurring reservation, the dynamic reprovisioning are the three main steps involved in this architecture, and there are the sub steps like a provisioning graph, telemetry history, and the target service level objectives, the job resource model in automatic inference, and the other like reservation replacement, the recurring reservation, and the like reservation resizing, a dynamic reprovisioning. Okay, please, I would like to request you to please make a note of the highlighted areas. Coming to the next slide, these are the above basic main features involved in the architecture, like extractor of target service level objectives, resource model, and the reservation placement, dynamic reprovision. What is extractor of target service level objectives? This is a subcomponent operates on a provisions graph, and this is graph capturing all inter-job data dependencies, which also capture the ingress and the egress operations as well. And the next one, the job resource model. This is also a subcomponent which takes a input detailed telemetry information on job runs, and which also takes a time series of resource utilization, which we called as a skyline, and basically which is the amount of resources used by us to in the job at a certain granularity, basically typically a 1 minute. And the automatic inference module outputs the service level objectives and the job resource model in the form of recurring reservation. And these recurring reservation requests for a newly observed periodic jobs are and continuously share to refining existing ones, which we call as a slow time scale. For example, mm, it could be a day, like the like a 1 minute in your previous example. It could be a 1 day in this one. And the next one, the inferred service level objectives and the job resource model feed the resource reservation component automatically every time. And that Morpheus allows the user for service level objectives and the job resources and the model sign off and override. Next one, the what is a reservation replacement? The reservation placement, which is a service level objective and the job resource model exposed in terms of recurring reservation request to a reservation placement mechanism. And the next one, the dynamic reprovisioning. To know about the dynamic reprovisioning, it's a variability in job execution, job execution to execute the whole thing in a single way, like the component continuously monitors the rate of progress of the job with respect to the amount of reservation consumed. And if progress appears slower faster than the expected, it also records that, and along with that, it also records the component automatically adjusts the reservation by tweaking the resources and the provision for reservation. Next one, the Morpheus implementation. How the Morpheus was implemented. Builds upon the Alliance reservation system, which we extended to accommodate periodic reservations. This allocation problem itself poses a substantial algorithm challenge. For this, actually, in this presentation, we actually designed a novel online packaging algorithm, which is specified for periodic jobs. And coming to the next slide, in this is the understanding life of a periodic job. Let's understand the period life of a periodic job. The user periodically submits the job X with a manually provisioned resources, and also the Morpheus enforces the service level objectives via recurring reservations. And the dynamic reprovisioning component also monitors the job progress online, and it also increases the decreases the reservation time, and it also mitigate inherent and execution variability, and it also constantly feeds back the step to the PG and the information of the neurons for continuous learning and refinement of the service level objective and job resource model. The next slide, the current limitations. These are the so, some highlighted limitations of our much discussed solution of the Morpheus. The first one, control over globally shared resources. The second one, the support of non-periodic jobs. Third one, automatic SLEs. What is an SLA? SLE is a service level agreements. SLE means a service level agreements. What is control over globally shared resources? It is, in this, the Morpheus relies on the underlying resource management infrastructure, like that is an Apache Hadoop or Yarn in our current implementation, and it only enforce a container level resources such as a CPU central processing unit or memory, but lacks the control or being globally shared resources like bandwidth on switches, like DNS server. And the next one, support for non-periodic jobs. It support for non-periodic jobs means it supports both periodic and non-periodic reservations, but does not automate the service level objectives and the job resource model extraction for never seen before jobs. And in support for non-periodic jobs, the service level objective extraction is remains an open problem for a never seen before jobs. Then the last one, the automatic SLAs, the automatic service level agreements. In this, the Morpheus provides an important building block towards it, but not aim at the delivering full-fledged automated service level agreements. A full service level agreements typically includes specifications for the business economic or business aspects for a provide user agreement. To give an example, it may include the cost of a unit resources or the threshold of expected service level objective attainment or the legal or financial consequences of missing target service level objectives, and limits, and it also limits the how much a dynamic reprovisioning is allowed and changing consequences, etc. Coming to the next slide, it is an implementation of the above algorithm. Okay, this is a these design are implemented as extensions to Apache Hadoop and Yarn. Referring back to the architecture, three components are implemented. As the first one, the automatic inference engine operates as a standalone service, which means that it continuously consumes a provenance and telemetry data and submits a reservation request to the resource manager in YARNs. and that is an centralized scheduler component via its REST endpoint. The second one is a reservation placement component which implements a low cost as in process of functionality of RM. Third, the dynamic reprovisioning mechanism, which is which implements as a monitoring thread in RM and which also observes a job resource request and triggers resizing of reservations, which indeed also observes the job resource requests and triggers resizing of reservation. And the explained above components are highly pluggable and can easily specialize to a leverage framework specialized specific knowledge. This is the implementation as extensions to Apache and Hadoop yarn. Next one, evaluation, which demonstrate the effectiveness and the scalability of Morpheus through simulations and cluster runs. In this, the first step is for the in this the setting of the environment, which involves five steps, which is a two production trace and a synthetic benchmarking suite known as enterprise trace, and the next one a 1 month trace of jobs running on a large 50K node production Cosmos cluster. Third one, Hadoop trace. And the next one, a 3 month trace, which is derived from a 4,000 nodes production Hadoop cluster. The last, the standard TPC benchmark running on Hivtage at a 10 terabyte scale. And this is the performance of enterprise trace. Here, first, we challenge the Morpheus in a simulation based on our largest dataset, like the enterprise trace. For this dataset, we have a fully provenance graph and telemetry information, the which are the first most basic things, and we can test all the components of the Morpheus. So we can test all the components of Morpheus and sensible service level objectives for most jobs. The second one, which is a pressing question we want to answer, is whether the service level objectives we derive are representative of user expectations or not. Short of a full scale study, we study reliable proximate metrics, a job success or a failure. Second, we observed Morpheus service level objectives target extractors successfully derive service level objectives for over more than 70% of the millions of instances in a periodic job, and it based on the enterprise trace. For the remainder, we have to little data on our trace to derive SLOs, the service level objectives, with a good confidence. Okay. In the next, the ratio between the used and provision indicates that we achieve a high utilization, which says that the when the ratio between the used and the provisioned, saying that it has an high utilization, even though we rely solely on the guaranteed provisioning. While many of the user compensates with the under allocation via opportunity fair sharing. Last conclusion, to conclude or say summarize the entire points, Morpheus is a system designed to help large companies manage their computer clusters more effectively and to reduce the negative impacts of the unpredictable job downtime. Builds on It will be helpful if we build on automatically deriving service level objectives, and relying on recurrent reservations and packing algorithms, and dynamic reprovision. Thank you.